Hi, I've got two other videos you might want to check out aside this one, and I'm going to link that up right now. The first one introduces matrices, including the definition, addition, and subtraction of two matrices. It also covers scalar multiplication and multiplying one matrix by the other. If you are only interested in examples on how to multiply two matrices, you should probably skip to the 11th minute. The first few minutes of this will just provide some background on the determinant of a matrix. Okay, so if you're interested in that one, yeah, just hit play. Hi, I'd like us to talk about the determinant of a matrix. And for this, we are talking about a 2 by 2 matrix. I already have, previous videos that talk about the order of a matrix. So when I say 2 by 2, you'll probably understand what I mean. If you don't, you probably need to check that video out. So I'm going to link it up now. Just click and check. Okay, so a 2 by 2 matrix is in the form of ABCD, if you like. Okay, so the determinant of that, if you like, will be ABCD. And this is what we want to look at. Just a quick background about this. Say we wanted to solve the system of equations that we have right now. One way to do it would be to eliminate y and then find x, and then afterwards substitute to find y. Say we wanted to eliminate y. In this case, we would have to multiply the first equation by b2 and then multiply the second one by b1. And if we did this, our equation, the first equation, will become a1 b2 x plus b1 b2 y plus c1 b2 equals to 0. And the second one will become a2 b1 x plus b1 b2 y plus c2 b1 equals to 0. As you can see, these two will then look the same. If we decide to take let's call this equation 2 and let's call this equation 1. So if we deduct equation 2 from 1, we will have a1 b2 minus a2 b1. They both have x in common, so I'm going to just factor that out. The mid terms there will cancel each other out, and then I would have c1 b2 minus c2 b1 equals to 0. Next, I make x the subject of the formula, and then what I will have will be x equals to c1 b2. Oh well, c2 b1 now, c2 b1, then minus c1 b2 divided by a1 b2 minus a2 b1. Okay, now as you can see, this is a fraction, and the value of this fraction will only exist if a1 b2 minus a2 b1 is not equal to 0. Okay, so this particular factor is very important. Now this factor, if you wanted to write it, you would see that we could easily write it as a1 b2 and a2 b1, if you like. And this will be our determinant. This is our determinant. In other words, if you want to find the determinant of a matrix, you simply pick the elements in the leading diagonal, which is a1, multiplied by b2, then you subtract the other one, which is a2 and b1, so minus a2 b1. That's how you find the determinant of a 2 by 2 matrix. Okay, and obviously you can see how important it is in finding the solution of a quadratic equation, how important it is to know whether it exists or not. Okay, so a matrix that has its determinant to be 0 is called a singular matrix. Next up, we will look at how to find the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. To find the inverse of a 2 by 2 matrix, say the matrix is A1, A2, and B1, B2. There are a number of steps to follow. We should take a look at those steps. The first step is to find the determinant of the matrix. The second step is to find the matrix of cofactors. The third step is to find the transpose of the matrix of cofactors. The fourth step is to divide the matrix that you find in step 3 by the determinant. Now that we know all the steps, let's begin. The first one is to find the matrix, and to do that, as A1, A2, B1, B2, we will multiply the elements in the leading diagonal first. So we have A1, B2, and then we subtract the product of the other one, which is minus A2, B1. And that gives us step 1. For step 2, we have to find the matrix of cofactors. Now, to do that, this is what you do. Consider that each of these elements in this matrix have got their positional signs. So A1 has positive, this is negative, and this is negative, this is positive. I'll show you how to use that in a moment. Now, what you do is to produce a matrix of cofactors. The matrix of cofactors is like a matrix that contains many matrices of the positions of the original elements. This is what I mean. To find the matrix of cofactors for the position of A1, cancel the row of A1 and cancel its column. You will see that what you have left is B2. Now, what you do now, and you also see that the sign for A1, the positional sign for A1 is positive. So what you do is you put down B2 where A1 should be. So this will be B2. And note that that will be positive. Okay. Now, for A2, this is what you do. Cancel the row for A2 and cancel its column. So for the position of A2, you have minus B1. Okay. For the position of B1, cancel its row and cancel its column, and note that the sign there is negative. So for B1, we'll have negative A2. And then for B2, if we cancel the row and cancel the column, we have A1, but it is positive. Now, this is your matrix of cofactors. The principle is generally the same for a 3 by 3 matrix, but we will look at that in another video. For step 3, we find the adjoint matrix, which is the transpose of the matrix in step 2. Finding the transpose just means that when you pick the column here, you change it to the first row. So instead of this being the column, you then have it as a row B2, negative A2, which also means that the second column here will become the second row, which will be negative B1, A1. This is called the adjoint matrix. So you call it ADJ of the first matrix here. We may name that matrix matrix A. So this will be the adjoint of A. Sometimes it's also called the adjugate. The adjugate. Okay, now that we have the matrix of cofactors, the last step will just be to divide the matrix of cofactors. We divide the adjoint matrix by the determinant. So step 4 will be 1 over A1B2 minus A2B1. Obviously I'm doing that because we are dividing by this. Okay, so if you want to divide by 2, it's the same thing as multiplying by 1 over 2. So 1 over that multiplying b2 minus a2 b1 a1. This here is the inverse of matrix A. Now in many textbooks where sometimes you may not see that it's been proved or it's been shown that this is the inverse matrix, this could actually appear as a formula. Now, how is this a formula? The original matrix we have is A1, A2, and B1, B2. Now, there are two things. What the formula does is it keeps the first step and the second step for you. You can find the third step by interchanging the elements in the leading diagonal so that it becomes B2, A1. So all I've done is to put B2 where A1 is and put A1 where B2 is. So after interchanging that, the next thing you want to do is to put a negative in front of the other elements in the other diagonal. So instead of A2, you then have negative A2 and then negative B1. So you have negative A2 and negative B1. This here is your adjoint matrix. If you look at it, you see that they are essentially the same thing. Now, all you just need to do is to multiply this by 1 over the determinant. And the determinant is A1 B2 minus A2 B1. We're going to quickly take an example. The example is find the inverse of matrix A, which is 1, 2, 3, 4. We want to find A inverse. Remember that the first step is to find the determinant, and we do that by multiplying the elements in the leading diagonal and subtracting the product of the elements in the other diagonal. If we do that, we get 4 minus 6, which gives us negative 2, which means that the determinant of A, we can call it det A, or if you like, write it this way, is negative 2. For the second step, if you remember, we need to find the matrix of cofactors. And we do that by cancelling out the row of position 1 and its column so that you have 4 left. Remember that the signage is also important. So we should have 4 written here. So this should be 4. For position 2, remember that will be a negative. I might as well write it. This is plus minus, plus minus. So for 2, we cancel the row and cancel the column. We have negative 3 for position 2. Then for position 3, we cancel the row, we cancel the column. So you have negative 2. And then for position 4, we cancel the row, cancel the column. There. So you have positive 1. This is the matrix of cofactors. For the third step, we find the adjoint matrix by writing down the transpose of this matrix. So the column here becomes a row. So this will be 4 minus 2. And this column here will be negative 3 and 1. This then is the adjoint matrix. That's the adjoint of A, or the adjugate of A. What we are left to do is to then divide by the determinant. So we have 1 over negative 2 multiplying 4, negative 3, negative 2, 1. And if we simplify this, we will have negative 2, 1, negative 1.5 if you like, and negative 0.5. And this is the inverse of matrix A. We're going to stop here. In the next video, I expect to deal with the determinant of a 3 by 3 matrix as well as the inverse. But before I go, I just want to show you that we could have found the inverse by skipping the first two steps if we used the formula. Remember that I told you that what you need to do is to interchange the elements in the leading diagonal to get the adjoint matrix. So ADJ of A, you simply interchange the elements in the leading diagonal. So that gives you 4 and 1. And then multiply these other two elements by minus. So this gives us minus 2 and minus 3. And then the next thing would just be to divide by the determinant. We already found the determinant to be negative 2. So we divide each of the elements by the determinant. So A inverse will be 4 divided by minus 2, which is minus 2. Minus 2 divided by minus 2, which is 1. Minus 3 divided by minus 2, which is 3 over 2, or 1.5. And 1 divided by minus 2 will be minus 1 over 2, which is A inverse, the same as what we got here. So if you like, you could go through the shortcuts and you'll be totally fine. Again, like I said, see you next video. Bye.